Assalamu alaikum wa rahmatullahi wa barakatuh. You are welcome to the 5th edition of our online class. This morning, inshallah, we want to look at integration, indefinite integral. Indefinite integral. What do we mean by integration? You know, I've told you in our previous classes, when we are dealing with this in our normal class, that when we are talking about integration, we make the opposite of differentiation. But a very good example is the situation we find ourselves. If the medical practitioner discover that somebody or suspect that somebody is having coronavirus, what they do with that person is that they isolate them or they quarantine them and take their sample. If their sample is positive, that means they are positive with COVID-19. What they do with them is that they will separate them, they will isolate them, they will keep them in an isolation. And what does that mean? It means they will differentiate them from the society. As simple as that. That is differentiation. But the integration part, after successful treatment, after the patient might have been treated and the test has been carried out and it was discovered that such a patient has tested negative twice, what the medical doctor do is that they integrate that patient to the society. That is, one Lord dining here, Papa Maujo, so that is to different. That is just to show you the meaning of differentiation and integration. So to show that they are one and opposite. Now, look at this. We said that the notation used to denote indefinite integral is just like S, but it is a long one, like this one. Look at how it is curved, then which look like an elongated S. So if y is equal to x raised to power n, we know from our definition of differentiation that dy all over dx is equal to what? Nx raised to power n minus 1. That is for the differentiation. But for the integration, if you want to integrate x raised to power n with respect to x, or if you like, you don't put it, it's the same thing as x raised to power n plus 1 all over n plus 1 plus c. And mind you, n must not equal to minus 1. Okay, maybe you cannot see here. Let me write at the top. So what we are saying is that if y is equal to x raised to power n and you want to integrate y with respect to y, of course, you are going to have integral, that is s raised to power n dx. And this is, the formula is saying that we are going to add 1 to the power and divide with the result of that power, that is n plus 1. What I did here was to add 1 to the power, to have x raised to power n plus 1 here, then over n plus 1 plus c, where c is the constant of integration. And of course, n is not equal to minus 1. Because if n is equal to minus 1, you have minus 1 plus 1 will be 0, and you have undefined. So it's not possible. So, of course, I will say where c is the constant of integration. So that is that. So in this case, we are going to form. And similarly, suppose our x has coefficient. Let's say we have y is equal to x, or probably we have ax raised to power n, and we want to integrate this. Of course, what we are going to have is that integral x raised to power, or ax raised to power n dx will be ax raised to power n plus 1 all over n plus 1, then plus c, and of course an is not equal to what? Minus 1. So that is that about the formula for integration. Now, how are we going to be applying this? The subsequent example. For example, let's say example 1 now. Example 1. We are told that if or integrate, probably integrate S square. We want to integrate S square, of course, solution is that we have integral S square dx, and this is the same thing as S according to this formula that x raised to power n plus 1. N here is now 2. That means we have 2 plus 1 all over 2 plus 1 plus c, and this is equal to x raised to power 3 all over 3 plus c, and that's what we have. So that is what we have when you differentiate S square. Similarly, that means that we integrate, that's what we are going to integrate S square, I mean. So similarly, if you integrate x raised to power 3, definitely you are going to have x raised to power 4 over 4 plus c. If you integrate x raised to power 4, that means you are going to have x raised to power 5 over 5 plus c, and so on. That is when it doesn't have the constant in its form. But when it has a constant coefficient, how are you going to do that? And the next example, we explain that. Example 2 now. We are told to find the following integrals. A, integral of 7 dx. B, integral of 7x dx. C, integral of 7x squared dx. Then D, integral 3 all over 2 x raised to power 5 dx. So these are the integral we have to evaluate. Of course, it is an indefinite integral because the limit of integration is not given. But the meaning of limit of integration, you understand this as we proceed. Or possibly you have understood it because you have been taught. You are just doing a general revision of all the topics you have treated so far, as far as our Ss3 is concerned. So, solution to this, solution. Solution, if you have 7 that you want to integrate, is the same as 7x raised to power 0. Generally, we don't need to do that. But for the beginner, I can put it for simplicity, that is integral 7x 7 dx is the same thing as integral 7x raised to power 0 dx. Where did I get that? I know 7 times 1 will be 7. So it's as if I have 1 here that is multiplying 7. That 1 can be represented as x raised to power 0, which is 1. 1 times 7 is 7. Why am I doing this? For the learner, so that you can understand how you are going to integrate. So what I have here is now going to be 7x raised to power 0 plus 1 all over 0 plus 1 plus c. And this is going to give me 7x raised to power 1 over 1 plus c. And that is 7x plus c. Which we don't need to put that one. Of course, that is 7x plus c. And don't forget, if you differentiate this, you are going to have 7, which means the opposite of that is the differentiation. The second one, so that is that. So the second one, we have integral 7x dx. Of course, that 7 here is same thing as if you have 7x raised to power 1. And this is equal to integral 7x raised to power 1 dx, if I like, because x raised to power 1 is same thing as x. for simplicity, so that you can easily understand it. And that is 7x raised to the power 1 plus 1 all over 1 plus 1 plus c. Don't forget, c is the constant of, in some textbook they use k to denote the constant of integration. It's still the same thing. So this is now equal to 7x squared all over 2 plus c. And if I like, I can write this as 7 over 2 x squared plus c. It's still the same thing. So that is that. Then the third one. Okay. C, we have integral 7x squared dx, which is equal to, of course, 7x raised to the power 2 plus 1 all over 2 plus 1 plus c, and that is 7x raised to the power 3 all over 3 plus c. So that is that. And if I like, of course, I can write it as 7 over 3 or raised to the power 3 then plus c. You see the constant of integration. So d, in d we are given integral 3 all over 2 x raised to the power 5 dx. X raised to the power 5 dx. And this is the same thing as 3 all over 2 x raised to the power 5 all over 5. You can separate it. It's better you put it in bracket, because what you have here is going to multiply. What you have here is x raised to the power 5 plus 1 all over 5 plus 1. Then plus c. You are seeing the constant of integration. So it's better you put bracket, because by the time you integrate this, the denominator is going to multiply to that we have here. So that's why it's better to put it in bracket. So this is equal to, we have 3 all over 2, open the bracket. This is x raised to the power 6 all over 6 plus c. And that is what? 3x raised to the power 6 all over 12 plus c. 3 can go here, I have 4. 3 can go here. I've told you that whenever you want to do a cancellation, it has to be a net cancellation. Otherwise, you get 0 in that step. So 3 can go here, I have 1. 1 times x raised to the power 6. That is x raised to the power 6. All over 3 in 12, I have 4. Then plus c. So that is that about that. I hope this is very clear and straightforward. The only area you need to be very careful is when you are integrating something like this. That has a denominator. If your coefficient has a denominator, you should know that by the time you integrate this, you are going to multiply this with the denominator, so that you have that. So please take note of that. Now, the next area we are going to look at is the integration of polynomials. Integration of polynomials. Integration of polynomials. Example 1. Find the following integrals. A, we have integral x squared plus 2 all over 5 x raised to the power 4 minus 3 dx. Then b, we have integral 3x squared minus 4x everything all over 8x then dx. So, solution to this. I hope the question is very clear. X squared plus 2 over 5 x raised to power 4 minus 3 dx. Then the second one we have 3x squared minus 4x all over 8 dx. So we want to integrate that. Solution. A, if I like, I can rewrite that A as x squared plus 2 over 5 x raised to power 4 minus 3x raised to power 0 dx. For simplicity or for the purpose of the beginner, because 3 minus 3 here is the same thing as minus 3x raised to power 0. So that any number raised to power 0 will be 1. 1 times 3 is still 3. So of course, this will now give me x raised to power 2 plus 1 all over 2 plus 1 plus 2 all over 5. Open the bracket. X raised to power 4 plus 1 all over 4 plus 1. You don't have one new about this, that you have to have a separate bracket for that. Minus 3x raised to power 0 plus 1 all over 0 plus 1 plus c, of course. C is the constant of integration. So you proceed. That is equal to x raised to power 3 all over 3 plus 2 over 5. Open the bracket. If you integrate this, 4 plus 1, here 4 plus 1 is 5. X, that means x raised to power 5 all over 4 plus 1, which is x raised to power 5 over 5. So we have x raised to power 5 all over 5. Close the bracket. Then here, of course, we are going to have minus x raised to power 3x raised to power 1 all over 1. So minus 3x raised to power 1 over 1. Then plus c, of course, that is the constant of integration, plus c. So that is what we have. And this is equal to what? X raised to power 3 all over 3 plus 2 times this. That is, we have 2x raised to power 5 all over 25 minus 3x raised to power 1 over 1, which I don't need to write because minus 3x divided by 1 is still 3 minus 3x, and x raised to power 1 is still x, then plus c. So that is the solution with that first one. That is the solution. And if you like, of course, you can have it as 1 all over 3 x raised to power 3 is still the same thing, plus this one is 2 all over 25 x raised to power 5, then minus 3x plus c. So if you like, you can leave it like this, and if you like, anyone you did or anyone you desire to do, you are very, very correct. Either you leave it like this or like this, it's still correct. Then the second one, it is better for me to split it, because don't forget, mathematically, if you have a plus b all over c, a plus b, if you have a plus b all over c, mathematically the meaning is that you have a over c plus b all over c. That means you are using this to divide this, you are still using to divide it, while plus in the middle. And likewise, if you have minus a minus b all over c, it's still the same thing as a over c minus b over c, is still the same thing. So that is that. So the second one, we can have it as this integral. We have 3x squared minus 4x all over 8x, close the bracket, dx is the same thing as, open the bracket, we have 3x squared all over 8x minus 4x all over 8x. So dx, you can split it like that. Mathematically, it's very correct, just like what I've done. So this and this. So in this will remove the power. You now have 3 over 8x here. Here, x will cancel x. 4 here 1, 4 here 2. That means you have minus 1 over 2, then dx. So what we are going to have now is this. You are going to have integral 3x all over 8 minus 1 all over 2, close bracket, dx. And this is equal to, of course, raised by 1. This is named as s raised by 0, if I like. S raised by 0. So this will now be what? 3 all over 8, x raised by 1 plus 1, all over 1 plus 1, minus 1 over 2, then x raised by 0 plus 1, all over 0 plus 1, then plus c, where c is the constant of integration. So this is now equal to 3 all over 8, close the bracket, 2x raised by 2, or x squared, all over 2, then minus 1 all over 2, x raised by 1 over 1, then plus c. So this is equal to numerator and denominator. This one with 3 times it, that is 3, or if I like 3 over 16, if I like, x squared minus 1 all over 2x plus c. So that is what we are going to have, and that is the solution of the second assignment. So that is what we are going to have. We have 3. What I did there was to multiply that denominator 8 multiplied by 2, we have 16, and the other one, of course. So that is that. So inshallah, I'm going to copy your assignment here, and at the same time I will send it on the website, on the school website, so that you can see. Or I want to copy it first. If you are having difficulty in uploading your assignments on the system, you can solve it in a sheet of paper, snap it, and send it to my WhatsApp using my phone number. Inshallah, we are going to meet on Wednesday by Allah's mercy. Subhana rabbika rabbil izzati amma yasifun wa salamun ala mursalin walhamdulillahi rabbil alamin.